Welcome to General Chemistry Mini Lecture Series, Lecture 4, Measurements and Uncertainty. Let's first talk about measurements in chemistry. Okay, there's one rule you have to remember. You need always to record your measurements with both a number and a unit. So you cannot just write down a number then without units. For example, here, 5.55, if you don't write down this ml, which is milliliters, then no one knows what the unit you're talking about. Okay, always the measurement, also, of course, that's the value, and unit. Most of the measurements in the UIs are made with English system. Okay, so we use units like miles, gallons, and so on and so forth. So the disadvantage of using the English system is that the units are not systematically related to each other. So you see 1 pound equals 16 ounces, 1 gallon is only 4 quarts. It's not 16. You see, and 1 yard is 3 feet. They are not really systematically related. So that's the kind of the disadvantage of English system. Then the other one, is used in most other countries, is called the metric system. And all of those units, they are ton-based. So you see, they are systematically related. And those units are something like, kilogram for mass, meter for length, and so on and so forth. That's the measurement. And there are a total of 7 base units in the metric system, and we also call the SI system, metric base. Since this is chemistry, I will talk about the chemistry unit first. Okay, the amount of substance in chemistry, we use mole. And this is the abbreviation for mole, MOL. For electric current, so the base unit is ampere, and then the base unit abbreviation is just capitalized A. And we have mass in grams, time in second. Those are the 7 base units. And there are other SI units that can be derived from those base units. So there are many more of other SI units. But in terms of base units, we have this 7. So we say, the SI unit, the advantage there is they are all ton-based. Here are the prefixes, depending on what your base unit is. Okay, if we take meter, that's the unit for length. 1 meter, look at here, that's 1 meter, 1 times 10 to the 0, that's 1. Okay, so that's just where the base unit located. Let me try it. Yeah, so that's right here. That's just 1, and if we use meters. And then 1 kilometer, you see K, kilo, then you will just add meter after that. So then that will be km, kilometers. Then 1 kilometer, here it means, equals 1,000 meters. So here the base unit, right here we are talking about meter. And then you can go up, you can have mega, that's a million, tera, that's a trillion. So trillion is 10 to the 12, million is 10 to the 6, kilo is 10 to the 3rd. If you go down, smaller unit, let's say centimeters, centi, that's 1/100th of a meter, 0.01 meter, or 10 to negative 2 meters. So therefore, this is the centimeter. And we can go to micrometer, μm, and then that's 1/millionth, 0.50, and then the ones in the 6th decimal place, or we can say 1 to 10 to negative 6 meters. So 1 micrometer equals 1 times 10 to negative 6 meters. So that's the way how you use those prefixes, and that's the way how you use those exponential notations. Units-wise, the ones at the bottom, they are the smaller ones. Let's say femto is the smallest unit in this table. 1 FM is 10 to negative 15 meters. That's the smallest in this table. And then the largest one, of course, the one on top, 1 terameters. Tm equals 1 trillion meters. The units, the one in the bottom, they are smaller, and then increases to the top. Measurements and uncertainty. Of course, whenever you perform measurements, you always have uncertainty. You will always have some errors, in other words. A measurement can only have one digit that is uncertain. In other words, the last digit in a significant figure for a measurement is uncertain. If we read the volume of the solution in this beaker, so now what are the certain values? We know this is 60 and that's 80. Here has to be 70. We know certain that the volume is larger than 70. And then right in the middle between 70 and 80, right here, that's 75. Actually, we also know 75 is somewhere here. So you see, now we have to guess, we have to estimate. If here's 75, I would say this may be 76 and 77, the lower edge of the meniscus. So this can be 77. Okay, so therefore I will read 77, or someone else may read 76. But if someone read 76.5, that is not correct based on those definitions. A measurement can only have one digit that is uncertain. Remember, the first digit, 70, we know that for sure. It's right here. But the second digit, I already estimated. And then if you estimate the third digit, it doesn't make any sense because the second digit, 76 or 77, they are already uncertain. Then further down, doesn't make any sense anymore to record more digits. So therefore, in this case, either 76 milliliters or 77 milliliters, or someone maybe even estimate 71 milliliters. But that, based on the definition here, that's still correct, okay? But if you have a total of 3 digits, that's wrong. Let's look at another example. So right here, you see, we know this is 90 and this is 100. Right in between, that's 91, 92, 93, 94, 95, 96, 97, and 98. I know for sure the volume is greater than 98 milliliters. So we can estimate as 98.8 milliliters, or someone else may estimate that as a 98.7 milliliters. So then the last digit is uncertain. Therefore, based on those definitions right here, those are the correct recordings. But if someone read this volume as 98.76, that will be incorrect because we already know the third digit is already estimated. That's for this one. One more. This is a burite, actually a section of burite. Okay, so for burite, you have to read actually from top to bottom. All right, that's 20 milliliters, 21, 22, and this is 23 right here. That's 22.5, and this 22.1, this 22.2. Okay, you see the meniscus of the liquid inside this burite is definitely between 22.1 and 22.2. It's right between these two. 22.1, 22.2, which means the second decimal place can be estimated. And that's the last digit. So therefore 22.18, that can be correct. I mean, that's at least the correct recording, or 22.19 or 22.15, it all should be okay. But if you say 20.185, that will be incorrect. That's against the definition right here. Therefore, that will be incorrect. And this one is good, this one is good. Therefore, you can see the quality of measurement is dependent upon the tool and the operator's skill. Beaker in this case, the single digit is uncertain. The single digit is already uncertain. So therefore, there's no need to record after the single digit. And then the graduate cylinder, so this one right here, the first decimal place is uncertain. Okay, so therefore the second decimal place, no need to record. And then for burite, the second decimal place is uncertain, it's estimated. Then if you go to the third decimal place of the fifth digit, so then that's not needed because it doesn't make any sense anymore. We don't even know, whether it's 22.18 or 22.19. Then you say it's 22.185. Doesn't make any sense. So let's talk about those uncertainty in measurements. Why you can have errors? So many reasons. Instrumentation quality may not be same, or your experimental design may not be good, or the operators, the experimenters' life skill may not be there. And there's something absolutely we cannot do is the nature's random behavior. We call them random error in this case. Let's talk about accuracy and precision. You can use both accuracy and precision to evaluate the uncertainty of your measurements or the quality of your measurement. So accuracy is an indication of how close a measurement comes to the actual value or the true value. That's accuracy. Then precision is an indication of how reproducible a measurement is. So that's a precision. That's a difference between accuracy and precision. I would like to use this diagram here to explain the difference between the two. Let's look at this one, kind of shooting target. We see right here 5 shots. We can consider that as 5 measurements. So they are all fall out of this bull's eye. So therefore the accuracy is not good. So this is low accuracy, this is high accuracy. And then kind of scattered all over the places. So they are not precise, they are not reproducible, or they are not close to each other. Therefore, the precision is also low. So this is low precision, this is high precision. Therefore, for this one, it has low accuracy and low precision. Then the next one. Okay, the accuracy is still pretty poor because, again, both eyes right here. But the precision is much better. They are all located next to each other. So therefore, this one is a high precision but low accuracy. Let's look at this one. The precision, again, scattered all over. That's low. You see on this side of the x-axis. The accuracy is kind of, sort of more accurate, but you cannot use the target shooting as an example. You can consider this as a measurement, okay, mass or volume, whatever. You see, these two can be averaged to somewhere here, and then these two can be averaged to somewhere here. So therefore, the overall average will be kind of more close to the actual value. So therefore, we call this high accuracy. And now here, that's low precision. How about this one? High accuracy, high precision. Okay, so that's the difference between accuracy and precision. End of lecture quizzes. This time, let's work on number 3. Which of the following represents the shortest length? First, you need to look at the units. You need to know which units are larger. Centimeter, millimeter, micrometer, and picometer. Centimeter is the largest one from this. So centimeter is the largest one, as equals 10 to negative 2 meters. And then the next one should be millimeters. Millimeter is the second largest among that group. It's 10 to negative 3. Then the next one is micro. It's 10 to negative 6. Then the last one is pico, 10 to negative 12. Then 1,000 picometers. 1,000 picometers, that's definitely smaller than 10 centimeters, smaller than 10 millimeters. You can actually carry out those calculations to compare. So now, how about micrometer? Let's see. This is a 10,000 micrometers, which means negative 6 meters. And here, for B, we have 1,000 picometers, 10 to negative 12. 1000 is 10 to the third, so therefore times 10 to negative 12, that's 10 to negative 9 meters. And here we have 10,000, so that's 10 to positive fourth, then times 10 to negative 6, then that would give us actually 10 to negative 2 meter. So now we are comparing 10 to negative 2 meter, that's actually 10,000 micrometers, with 10 to negative 9 meters, which is actually 1,000 picometer. The correct answer for question 3 should be B. This is a mini lecture 4, and I will see you guys in lecture 5.